Good day to you, children. In the previous chapter, that is Introduction to Euclid's Geometry, while studying the parallel lines, we learnt about various geometrical elements such as number 1, point. If you remember, then a point is a non-dimensionless geometrical object which does not have any length, breadth or height, and we denote point using a simple dot, and it is written as, it is labeled as a capital letter A, B, C or anything. We always use capital letters to name the points. The second element or object which we learnt about was line. In line, we went through straight line, ray and a line segment. We also learned that they are labeled as, a straight line is labeled as, say if a line AB is present, then it is labeled as AB with a bar on top which has two arrows at both the ends. Both the arrows represent that the line can be extended in both directions. Similarly, if it was ray AB, rays have one end point and they can be extended in the another direction. So whenever we represent A, the bar on top of the letters is always has a arrow at one of its ends, whereas the other end does not have the arrow. It shows the end point which is present in the ray. And whenever we write line segments, say line segment AB once again, if the line segment AB is present, then the notation which we use is a simple bar with no arrows on either of its sides, because a line segment is a terminated line which cannot be extended further. So it is only represented with a bar. But in the chapters which we will study in the future, we do not use these kinds of notation. It is understood what we are dealing with is a line, ray or a line segment based on the context or the situation itself. If we were to represent a straight line, ray or a line segment, say which we will just write AB. We will just write AB. We do not use these notations, but these are the actual notations. We do not use them, but just understand based upon the context what the AB stands for. Suppose we are talking about angles, then AB will stand for a ray. If we are talking about parallel lines, then AB will stand for lines. And similarly, if we are talking about triangles, quadrilaterals, pentagon or any polygon, then we are talking about AB as a line segment. So based upon the situation, we can represent AB to be anything, not just AB but any of the line, ray or line segments. Moreover, straight lines can also be represented using small letters like L, M, N, P, etc. Straight lines cannot just be represented using capital letters, but just a single small letter, which we also studied in the last class. I hope you have written the notes in the last chapter itself, and so now we move ahead to angles. First, let us look at the definition of angles. Angles are when two rays originate from a single point, which is also known as a vertex. So when two rays originate from a single point, they form an angle. So if we were to look at the figure, if we were to draw how it looks, then consider this is our first ray. Ray has one arrow mark and another end point. Ray OA. This is our first ray, and now this is our first ray, and we should have two rays which will originate from the same point. So this is our point. Now our ray should originate from, another ray should originate from this point itself. So this is our second ray. Say this is ray OB. So now here in between these two rays we get an angle. So when two rays OA and OB, not just OA and OB, it can be anything, we are naming them as OA and OB for our convenience. So when two rays originate from a single point, they form an angle. So here the two rays have formed the angle BOA or angle AOB. Since we measure the angle from bottom like this, we measure the angle from here to here, we name it as angle AOB. If we were to measure it from here to here, from the top ray to the bottom ray, then it would have been BOA. Since we are measuring it from bottom ray to top ray, it will be angle AOB. Both the representations are same. Otherwise, you can just call it as angle O. This is also correct. Since we have only one angle, at this point we have only one angle, so angle O also suffices. But if there was a second angle, say there was a third ray C, now we have two angles which have been formed at the same point. This is angle 1 and this is angle 2. So two angles have been formed by three rays at the same point O. So now we cannot name our angle as just angle O. We have to use three letters to represent them. One, we have angle AOB. This is our first angle. Angle AOB is the first angle. Angle AOC is also angle AOC, and the last one which we have is angle BOC, angle BOC. These are the three angles. Actually we have three angles. This is the third angle. Three angles which have been formed by three rays at a fixed point. So an angle is formed when not just two, when two or more rays originate from a single point. Now we have types of angles. Here we classify angles based on how much they measure. So based on that we have first type, that is acute angles. Write it here, based on measurement, based on how much their value is, we classify angles as acute angles. They are always less than 90 degrees, right? Acute angles are always less than 90 degrees. So if I were to draw an acute angle, then my first ray OP, now I am naming them differently, and my second ray OQ. This is my acute angle which is less than 90 degrees. If you want to confirm that it is less than 90 degrees, then you can use a protractor, which by using which we can measure angles. So if you look here, this is 0 degrees, this line represents 0 degrees, and 90 degrees is here. Our ray OQ meets at 45 degrees. So this angle is 45 degrees, which is less than 90. So angle POQ, which is equal to 45 degrees, is acute angle, or just acute. Second angle which we have is right angle. Right angle measures exactly 90 degrees. Right angles always measure exactly 90 degrees. So now what you have to do is pause the video and draw a right angle in your notebook. Use the protractor, use the scale, use your geometry box and draw a right angle in your fair book by pausing the video right now. Moving ahead, we have a third type of angle which is called as obtuse angle. They always measure more than 90 degrees but less than 180 degrees. Obtuse angles always lie between 90 and 180 degrees. So if I were to draw an obtuse angle, then our ray X, Y and here, this is our obtuse angle set. Angle Y, X, Z is obtuse. If you want to confirm, then you can draw an obtuse angle on your own and measure it. You will find that it is always greater than 90 degrees but less than 180 degrees. And the fourth type of angle which we have is straight angle. Straight angle, just like right angle which always has the same measurement or same size, a straight angle has a measurement of 180 degrees. A straight angle always measures 180 degrees. So a straight angle is nothing but a straight line. A straight angle is formed whenever you have a straight line. It is also known as the angles of straight lines. Here you can see angle AOB. This is our angle here. This was our angle. So this is angle AOB, which is equal to 180 degrees. You can measure it here. See. You can see here. Starting from 0, B, OA. If you measure it, it is exactly 180 degrees. And the last type of angle which we have based on the measurement is a reflex angle. The fifth type of angle is reflex angle. It always lies between 180 degrees and 360 degrees. A reflex angle is an angle which measures more than 180 degrees but less than 360 degrees. 360 degrees angle we call it as complete angle. So you can see here, if we were to draw a reflex angle, then this is our ray A, B, and now here we have it, C, ray BC. So this is our reflex angle. From here we measure reflex angles from the top ray to the bottom ray, like this. Not this, this is wrong. This will be acute angle. This is the reflex angle which measures more than 180 degrees was here. 180 degree was here up to here, but it is more than 180 degree but less than 360 degrees. It is a reflex angle. So if you look in our acute angle here our acute angle is 45 degrees. The remaining portion, this outer portion, shows the reflex angle. So whenever we have a point and two rays, there is not just one angle but two angles, two rays and one point. We have two angles. One is acute and the other one will be reflex. If the other one was reflex, we have the inside one as acute. Just not confuse, let's not confuse it. Here we can see that this is the reflex angle ABC. Now with the last one, which is the sixth one is complete angle. A complete angle is always equal to 360 degrees. Just now we saw that a straight angle which is equal to 180 degrees is always present in a straight line. Whenever we are dealing with straight lines, the angle which is present in straight lines is a straight angle. But similarly, in a complete angle which is always 360 degrees, it is present in the circles. The circles, or from the center of the circle, if you measure from some point on the circle and come a complete round to that point again, you would have covered complete 360 degrees. So complete angle is present in circles. In the previous section, we saw how angles were classified into different types based on their measurements. In the second main, we are classifying angles based on their. There are two types of angles based on their sum. First is complementary angles. Complementary angles. If the sum of two angles is 90 degrees, then they are called as complementary angles. Say for example 30 degrees and 60 degrees. When you add these two angles, we get their sum to be 90 degrees. So two angles whose sum is a right angle, they are known as complementary angles. The second type are known as supplementary angles. If the sum of two angles is 180 degrees, then they are called as supplementary angles. Say for example 100 degrees and 80 degrees. The sum of these two angles is 180. So the pair of these angles, this pair of angles is called as supplementary angles. In complementary, the sum of two angles should be a right angle, whereas in supplementary, the sum of two angles should be a straight angle, that is equal to 180 degrees. Now let us look at different kinds of pairs of angles. You guys have three pairs of angles, three types of pairs of angles. The first one is adjacent angles. A pair means two angles. Okay, a pair means two. So pair of angles means two angles, in which the first one is adjacent angles. In adjacent angles, the angles share a common vertex as well as a common arm. The rays of the angles which we see are also called as arms, and the point which they originate from is called as the vertex. You know that already, I hope so. So now in adjacent angles, the angles not just share a common point, but they also share a common arm. If you look at the angles here, angles AOB and angle AOBOC. If you look at the angles AOB, this is the first angle, and the second angle BOC. If you look at these angles, then they have a common vertex as well as they have a common arm between them. They are neighboring angles. They lie side to side. So these kinds of angles are known as adjacent angles. Similarly, the second type of angles, before we forget, these rays are known as arms. They are also called as arms, and this point, it is known as vertex. Before you forget that, make sure you note it down. So now it is true for all the angles. This is also an arm, this is also an arm, this is not just this one. These two rays OB and OC are also arms of the angle or the rays. So now we saw that adjacent angles, they have a common point as well as a common arm. Similarly, we have something known as linear pair. We have something known as linear pair, and in linear pair, if the sum of two adjacent angles, if the sum of two adjacent angles is 180 degrees, if the sum of two adjacent angles is 180 degrees, then they form a linear pair. Here, look here. From the figure, we have two angles, Z, Y, W, this is our first angle, and W, Y, X or X, Y, W, this is our second angle. They have a common vertex and a common arm. Both the angles have a common arm and a common vertex. So angle ZYW and angle XYW are adjacent. What we said, if two adjacent angles have a sum of 180 degrees, then they are called as linear pair. So now let us take our protractor and measure them. Look here, first angle ZYW. This is our angle from 0 here. This, make sure that your lines coincide with the ray. So 0 degrees, and here we have W. It coincides at 60 degrees. So our angle ZYW is equal to 60 degrees. Now similarly, let us measure the second angle, that is XYW. So once again, this should coincide with the vertex, and here the line should coincide. We are measuring it from here now. We are using the outer measurements. Before we use the inner measurements. We measured it like here, like this, right? Now we are measuring it like this, anti-clockwise, in anti-clockwise direction. So now if you look carefully, then this angle meets at 120 degrees. We are measuring it in the opposite direction. We are measuring it like this. So it met at 120 degrees. So angle XYW is equal to 120 degrees. Now if we were to take the sum of both those angles, angle ZYW plus angle XYW, which is equal to 60 degrees plus 120 degrees, we get 180 degrees. Therefore angle ZYW and angle XYW are a linear pair, right? They were both adjacent angles and their sum was 180 degrees. So they are linear pair. The third type of pairs of angles is vertically opposite angles. Vertically opposite angles. These type of angles are formed when two lines intersect each other. So if I were to explain it to you by a figure, then this is our line L, small letter. We'll use small letter denotations for line. This is our line L and this is our line M. So now when two lines have intersected each other, we get two pairs of angles. This is pair 1, this is pair 2. So we got two pairs of angles or two sets of angles. And these angles which are opposite to each other, you can look, this angle is opposite to this angle and this angle is opposite to this angle. These kinds of angles are called as vertically opposite angles. P is the point of intersection of lines. So whenever two lines intersect, the kind of angles which we get are called as vertically opposite angles. So now your job is to pause the video and draw two pairs of vertically opposite angles by intersecting two lines and label them. You have not just labeling them, you have to identify the pairs of vertically opposite angles which you get there. Alright, so take a note of the questions which are for your homework for today's class. This homework should be written, not just written, should be solved in your homework book. So the first question is, draw the following angles using a protractor. So the first angle is 35 degrees, then 90 degrees, third angle is 135 degrees, fourth angle is 270 degrees, and the last one is 0 degrees. You should use the protractor and draw them and label them. Now, and the second question is, identifying the following pairs of angles as complementary or supplementary. So they have given you pairs of angles, that is 5 sets of angles. So you have to identify whether they are complementary or supplementary. You know that if they are complementary, then the sum of the angles will be 90 degrees. If they are supplementary, then the sum of the angles will be 180 degrees. So based on this knowledge, you have to identify them as complementary or supplementary. The first pair is 30 degrees and 60 degrees. The second pair is 45 degrees and 45 degrees. The third pair is 130 degrees and 50 degrees. The fourth pair is 0 degrees and 90 degrees. And the fifth pair is 170 degrees and 10 degrees. Make sure that this homework must be written in your homework book without fail. That's all for today. Thank you.